Perfect. Perfect. Perfect.
Hello everyone, this is Chapter 1, Lesson 1.3. In this lesson, we are going to be talking about factors and specifically prime numbers and prime factor trees. Okay? So first thing that we need to talk about is what is a factor pair? Well, a pair is, two things together. Well, a factor are numbers that we can multiply together. So let me give you guys an example of a factor pair. So if I take the number 20 and I want to find a pair, right? A pair. I want to find two numbers that I can multiply that will get me 20. So let's think about two numbers. What numbers would give me 20? Well, let's make this easy. How about 2 and 10? If I multiply those two numbers, will that give me 20? Yes, it will. So that is a factor pair. Okay? So we just found a factor pair. Now, the more we do this, the more it's going to make sense, and we're going to try and solve this problem. So let's start off with example number 1. Okay, example number 1 says like this: the brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How many possible arrangements are there? Well, to figure that out, we just need to do some factor pairs. So we have 30 band members. So let's see, how many different kinds of rows can we make? Well, I'm going to show you guys a very easy way to do this. So we're going to take the number 30, and we're going to find out what numbers can I multiply to get 30. So let's see, what number can I multiply the number 1 to get 30? Well, 1 and 30. I'm going to make like a straight line like this. So how about 2? Does 2 go into 30? Yeah. So 2 times what's going to give me 30? 15. Does 3 go into 30? Yes, it does. 3 times what number will get me 30? 10. 3 times 10 is 30. Does 4 go into 30? No. Does 5 go into 30? Yes. So 5 goes into 30. What times 5 will get me 30? Well, that'll be 6. 5 times 6 is 30. And then there's no more numbers. So we just found all of the factor pairs. So this one goes with this one. This one goes with this one. This one goes with this one. And then this one goes with this one. So if we think about this, and let's see what the question says. It says, how many possible arrangements are there? Well, I'll tell you right now, they can have one row of 30 seats, or they can have 30 rows of 1 seat. So that's 2 different options. They can also have 2 rows of 15, or they can have 15 rows of 2 people each. Then they can also have 3 rows of 10 people, or 10 rows of 3 people. And then the last one would be they can have 5 rows of 6 people or 6 rows of 5 people. So there would be a total of 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible ways for them to arrange this band, this marching band. Okay, now let's do a few more examples and see if we can figure this out again. So let's list some factor pairs. Okay, so we have the number 18. Let's list all the numbers that we know can go into 18. So remember, I want to do this on a straight line. I'm going to start all the way over to the left. 1. What number times 1 will give me 18? Well, 1 times 18, right? What about 2? Does 2 go into 18? Yes. 2 times what? 9. Does 3 go into 18? Yes. 3 times what? 6. Does 4 go into 18? No. Does 5? And then that's it. So we just found all of the factor pairs. 1 and 18, 2 and 9, and then 3 and 6. Let's try another one. 24. So again, I'm going to draw this on a straight line. I have 1 and 24. What other number goes into 24? 2. 2 times what? 12. 3. Does 3? Yes. 3 times 8. And then 4 times what? 6. Okay. So there we go. We just found all of our factor pairs. All right, let's do one more example. 51. Ooh, this one's a hard one. Let's see. So we have 1 and 51. Does 2 go into 51? No. Does 3 go into 51? Yes, it does. Just to tell you how I know that, well, if I just add these two together, 5 plus 1, that gets me 6. And I know that 3 goes into 6. So now let's see, what number times 3 will get me 51? I already know this, and I'll tell you it is 17. Does 4 go into 51? No. Does 5 go into 51? No. Does 6 go into 51? No. Does 7 go into 51? No. Does 8 go into 51? No. And does 9? Nope. So that's it. We found our factor pairs, 1 and 51. This is what I was telling you guys about knowing your multiplication tables. It's very, very important that we know our multiplication tables. All right. That was example. In example number 2, we are going to learn about prime factorization and factor tree. Well, prime factorization is the composite number is written as a product of its prime factors. Well, we have to go back to what is a prime number. Prime number is a number that you can only multiply 1 and itself. For example, 1 is a prime number, right? 1 times 1. Is 2 a prime number? Yes, 2. So 1 times 2 is still going to get us 2. Is 3 a prime number? Yes. Only 1 times 3. 4 is not a prime number, right? Because it could be 1 times 4, and it could also be 2 times 2, right? It's only got one answer. A prime number only has one multiplication problem that's going to get us to that number. So 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number. Now, y'all would be like, oh, it's all the odd numbers. No, that's not true. That's not true. It can be a whole bunch of other numbers. Okay? So, prime factorization, and then a factor tree. A factor tree, you can use factor pairs, what we just talked about, to help find the prime factorization of a number. A factor tree is complete only when prime factors appear in the product. So for example, take a look at this one. All we're doing is we're breaking down this big number into smaller numbers. All right, so we found out that 2 and 30, and then we're breaking down this number, 2 and 15, right? And then we break down this number, 3 and 5. And then you can't break down 3 anymore, and you can't break down 5 anymore. So all you got to do now is take all your prime numbers and put them in order. So 2, 2, 3, and 5. And that is how they put it together. All right, let's do a few examples and see if we can get this done. In this example, we're going to learn how to do our prime factor trees. I have 3 examples that we can follow so then I can show you. Now, there are any kind of factor pairs that we can choose. Just remember that when you do your factor tree, what you're trying to do is try to get your prime numbers. So I usually like to start with the easiest numbers that I can think of. If you can think of easier numbers, you know, there's no wrong way to do it or no wrong numbers to choose as long as you're choosing your prime numbers. So I'm going to start with 2 and 24 because I know that 2 times 24 is going to give me 48. Okay, so I chose my 2 factor pairs. All right, there's nothing left I can do with that, so I'm just going to circle that 2. Now I'm going to break this down again. What numbers go into 24? I know 2 and 12 go into 24. Right, I can't break down this 2 anymore, so I'm going to start off with this 12. I know 2 and 6 go into this 12. Okay, there's nothing left to do with this 2, so now I'm just going to break down this 6. What 2 numbers give me 6? It would be 2 and 3. All right, now that I've got this, I'm done, and there's nothing else I can break down on this number. So now I just have to do my prime factors. How many 2's do I have? I have 1, 2, 3, 4. So that's 2 to the 4th power times 3. And that is my prime factorization. All right, let's try it with number 20. Let's see. What 2 numbers can I break down, or 2 factors can I use to get 20? Well, I'm going to try again. I'm going to start with something easy. So 2 and 10, right? I can't break down 2 anymore, so I'm just going to circle that. And now I'm going to break down 10. I can break it into 2 and 5. So there's nothing I can do with the 2, so I'm going to circle with that. And there's nothing I can do with the 5, so I'm just going to circle that. Now I just need to put it in prime factorization. So how many 2's do I have? I have 1, 2. So that's 2 to the 2nd power times, and what's left over is that 5. All right. Let's do 90 this time. Let's see, what can I do to break down 90? What 2 numbers can you think of to break down 90? Well, I'm going to try this. I'm going to try 9 and 10 because I know 9 times 10, right? 9 times 10 is going to give me 90. So let's break that down. All right, can I still break down the number 9? Yes, I can. So let's do that right now. What two numbers, if I multiply them, will give me 9? Well, I know it's 3 and 3. All right, so I can't break down 3 anymore, so I'm just going to circle that like this. Let's break down this 10. What two numbers, if I multiply them, will get me 10? Will be 2 and 5. And both of those are also prime. So now the last thing I need to do is I just need to put it in my prime factorization. So let's try this. I'm going to try to put them in order. So I have 1, 2. So 2 times, how many 3's do I have? I have 2 3's. So that's 3 to the second power. All right, times 5. And there we go. We just did our prime factorization trees. All right, if you need more help, please rewatch the video so you can break it down. This was example.
Perfect.